Hello everybody, and welcome to lesson 2 for algebraic proof. Today we're going to talk about the basics of proof by looking at something that you already know how to do very well, which is solving algebraic equations. Now, the first thing we need to talk about are all the different types of justifications you can use when you are proving an equation. Now, you already know how to do all of these things, you just might have forgotten the name for them. So, we have different types of property of equality, and basically they're manipulations we can use to solve an equation. So for example, if I know that A equals B, then I know that if I add the same thing to both sides, C, then A plus C still equals B plus C, so on and so forth. Similar idea with the subtraction property of equality, multiplication, division. The ones that you probably don't remember are things like reflexive property, and reflexive property just says that something equals itself. We're going to use that a lot more when we hit proper geometric proof rather than here in the middle of algebraic proof, but something equals itself. I remember it as in my reflection, which is the exact same as myself. That's how I remember it. I remember it's like reflecting in a mirror, something equals itself. Then we have the symmetric property, which says that if A equals B, then B equals A. So thinking about symmetry, that things are the same forwards and backwards. And then transitive property. If A equals B and B equals C, then A equals C. It's a chain reaction. So then we've got on the next page the distributive properties of equality. You can have these over two ways. You can have it over addition and over subtraction. Basically just says that you can distribute into a parenthesis. And notice my A can be at the forward or at the front or at the back of what's going on here. We've got substitution property of equality, which basically just says that if A equals B, then A can be replaced by B. Substitution property only works for numeric values. No matter how much you want to use this, when you have a congruent symbol, you may not use in a congruent statement, ever. Substitution is not valid for congruence, so this is going to trip a lot of you guys up. And what do I mean when I say valid for congruence versus valid for equality? Well, three of these concepts repeat themselves as properties of congruence: reflexive, symmetric, and transitive. And basically, we can only ever use all of the previous properties when we're dealing with an equal sign. And remember, we only deal with equal signs when we're dealing with actual values. So if I'm setting up an equation, part plus part equals whole, I have to use properties of equality in that situation. Whereas if I'm just talking about how two things in a shape relate to each other, if they are congruent, then I use this congruent symbol. So we have a reflexive property of congruence, a symmetric property of congruence, and a transitive property of congruence. So just be aware that there is a difference between the two, and it all comes down to which symbol you're using. Now let's go through and take a look at different properties of equality and what's going on in each one. So from the first step to the second step in this first example, to get from x plus 5 equals 9 to x equals 4, I had to use the subtraction property of equality. And it's property of equality because there's an equal sign. Then, number 2, we had to use division property of equality to get from negative 2x equals 12 to x equals 6. And then here in 3, quite clearly what I had to do was distribute. So it was the distributive property of equality over subtraction, because that's the symbol it's moving over. Now, let's take a look and see what properties are being illustrated down here. If x equals y and y equals 3, then x equals 3. That is a chain reaction. That is transitive property. And it's property of equality because I'm dealing with equal signs. Here, I see that I have something is congruent to itself. This here would be the reflexive, and it's not property of equality, it's property of congruence because we're dealing with a congruent symbol. Okay, and then 6, I have G and H are each 35 degrees, therefore G is congruent to H. This is the transitive property of congruence because two things are equal to the same thing, therefore they're equal to each other, therefore they're congruent to each other. Then down here 7, and given the figure below, measure of angle A equals x plus 5, and they show me down here in the diagram that A is x plus 5. This isn't really a property of equality or congruence. This is just a given statement. I would probably write given in the diagram. Bit of a trick question. So now let's look at some actual proofs. We use these properties of equality to justify our steps when we're solving an equation, basically. So here in my first example, you can see on my side right here, or my statement side, I have gone through and I've solved that equation in painstaking detail. For those of you guys who never write down anything and skip steps, it's got to stop at this point because otherwise you're not going to be able to do a proof. So they asked me to go through and solve this equation to prove that equation. So my first step is always what I'm given with the reason that I'm given it. So you're always going to see the first couple steps, maybe just the first step, as given. Then we go through and we solve the equation. So the first thing they did was they distributed that 2 here and here. And this is the distributive property of multiplication over subtraction. Then all they did the next step was just simplify. This isn't the property of multiplication because it's not happening on both sides. It's just simplifying. Then they added the 8 over for addition property of equality and divided both sides by 6. So I have the division property of equality. Now here I have 3 equals x, but that's not our standard way of writing x equals something. So what I have to do is I have to flip it around. X equals 3. And when I flip something around, that's my symmetric property, and I would write of equality back here. And then we're done with the proof. To show we're done with the proof, there are 2 things we can do. The first is to write QED in capital letters, which stands for a phrase in Latin, which means "and so it is proven." Or you could do the far more satisfying and modern version, which is drawing a little box and filling it in. I love drawing the box and filling it in. It's just so satisfying to scribble in that box at the end. So, let's take a look at the next proof. Here, they want me to prove the algebraic equation 3 over 2x minus 5 equals 9. Now, my first step is simply writing down the equation. That's my given. That's why we always have you guys copy the problem in your notes before you start solving it. Then, the next step, if I look, there's always more than one way to solve a problem. It looks like what they did was they multiplied everything through by 2 at that point to get rid of the denominator. So that would be my multiplication property of equality. Okay. Then they went through the next step and they added the 10 over to this side. So that's my addition property of equality. And finally, they had to get the x by itself, so they divided both sides. So the division property of equality. And we're done with our proof. We got to where we wanted to go. Now let's take a look at the next one. Here I've got this lovely equation. 5x plus 1 times 3 equals 18. Let's go ahead and just solve this thing straight through, remembering that there's always more than one way to solve it. I'm actually going to start by dividing both sides by 3. I'm going to avoid the distributive property. If you want to distribute, you can. But I think it's going to be slightly shorter that way. So I get 5x plus 1 equals 18 divided by 3 is 6. Then I subtract my 1 over. So I have 5x equals 5. So x equals 1. As a try me, I want you guys to fill in the reasons, right? I'll be checking that in class, so give it a shot. We are now going to go through and prove a proper geometric proof right now. So here I have a given statement, angle VGY is congruent to angle YGR, and this is my goal. I want to prove that the measure of angle VGR is 120 degrees. So my first statement is always what I'm given. Angle VGY is congruent to angle YGR. And over here, I'd write that that's given. Now, if I have the congruent symbol, and then I know I need to get down here to things being equal to each other, that means I need to, at some point, convert my congruent symbols into equal signs. So I'm going to go ahead and do that here in my second step. I know that if two things are congruent, then they're also equal. The measure of angle VGY is equal to the measure of angle YGR. Now I know some of you at this point are going crazy because that seems so obvious, and why on earth do I have to write that down? Well, in geometric proof, we have to be painstakingly obvious, to the point where you probably want to pull your hair out on several occasions. But that's just life. We can never, ever, ever do anything without giving a reason for it, including switching symbols. So here I do need this step showing that I had to go from congruence to equality. Now, I've got some more givens in this picture. I've got this right here and this right here. The picture is telling me that the measure of angle VGY is 9x minus 48, and that the measure of angle YGR is 5x. So my reason for that statement is that it's given in the diagram. Now, I can now make a beautiful little substitution by placing these values into this equation I wrote right here in my fourth step. So I end up with 9x minus 48 equals 5x through the substitution property of equality. And I'm now going to solve this equation for the next few steps. I'm going to subtract the 9x to get that negative 48 equals negative 4x with my subtraction property of equality. Do you want to point something out? Never, ever, 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 ever shorten the word substitution or subtraction. Just don't do it, because guess what? They're both sub. Don't tell me sub POV ever. I will count it wrong, because I will assume it's the other one. Okay, my sixth step then is division. So I get that 12 is equal to x. Property of equality. Now, I'm going to flip this around so it's in the way of writing it that I want to see. So I see that x equals 12. And remember, when I flip things around, that's the symmetric property. But I'm not done. They didn't ask for x. They asked for the measure of angle VGR. Well, the measure of angle VGR is this big angle here. So we're going to have to use our angle addition theorems to get that measurement. So for number 8, I'm going to write down the angle addition postulate, that the big angle, the measure of angle VGR, is equal to the part plus part. So measure of angle VGY plus the measure of angle YGR. That is my angle addition postulate that we learned about a while ago. So at this point, I substitute in the things I know. I don't know measure of angle VGR. That's what I'm looking for. Measure of angle VGR. But I do know these two pieces. We listed them way up here. I know that VGY is 9x minus 48, and that YGR is 5x. Well, I also know what x equals. So 9 with substitution. And again, I'm not shortening it because substitution and subtraction. And then in 10, I'm going to substitute in for x. So I'd have 9 times 12 minus 48 equal plus, what am I doing? Plus 5 times 12, again, for substitution. And yes, I have to write it twice. I know it's painful. Your hand will cramp. I do apologize, but mine's cramping already. So we're in this together. So for my 11th step, I simply simplify that side of the equation, which 9 times 12 gets me 108, plus 48, minus 48. I'm having a morning, aren't I? Minus 48 plus 60. Well, that means, final step, that the measure of angle VGR is in fact 120 degrees. So my 11th step was simplification. And so for that matter was my 12th step. Remember, it's simplification when it only happens on one side of the equal sign and it's not distributive property. So, and now I'm done. I put my little black box. Woo, we're done. Yay! So let's I want you guys now to just fill in the reasons on this proof here. Okay? We give you some givens right here, so you're going to start with your given. It's referring to this diagram here, and we'll check it in class. So thank you all very much, and we will talk to you in class. Thank you.